This guide is to create an OpenVPN tap bridge between two routers. The server's LAN will be on the 2 range. The example will bridge port 1 on the client to the server. The rest of the client will be on the 3 range. The top left will show the server's router and bottom right will display the clients. We first need to create the VPN security certificates between the 2 routers using OpenVPN. Open Google and search for OpenVPN download. On the install, click Customize and then select to install easyrsa. Once installed, we then need to open Windows Explorer and navigate to the easyrsa folder. Right-click the easyrsa file and edit with a text editor. I'll just show how to extend the VPN certificate's expiry date. Search for easyrsa_ca_expire. The values are in days, so we can increase these for a long future expiry date. Save the file and go back to Windows Explorer. We need to copy the path of the directory and access it using command prompt. Click the Windows Start menu and type cmd. Right-click on Command Prompt and click Run as administrator. Type cd and right-click to paste the easyrsa path from earlier. Then click Enter. Type easyrsa-start.bat and then Enter. Type easyrsa space init-pki. Type easyrsa space build -ca space nopass. Give a common name, example VPN1. easyrsa space build -server-full space server _ site A space nopass. Type yes. easyrsa space build -client-full space client _ site B space nopass. Type yes. Then type easyrsa space gen-dh. Go back to Windows Explorer and we need to copy the required certificate files to a new folder. Click into the PKI folder. Now just create a new folder in Downloads, for example, named OpenVPN config. First click into Issued and copy those. Then the private folder. Then copy C, A, and DH. We then need to copy these certificates to the client's computer, which has access to the client's router. I am using a virtual machine, so just copying one to another. Next, go back to the server's router and click the System tab and System. Just make sure the date and time is correct, because if any are wrong, this will invalidate the certificates. Now click Network and then Firewall and select Traffic Rules. Scroll down to the bottom and click the Add button. Name OpenVPN, Source Zone WAN, Destination Zone Device. Destination port 7500. Click Save, and then Save and Apply. We now need to download PuTTY to SSH into the router. Once installed, open PuTTY and type the router's IP address. In this example, 192.168.2.1. Log in and type opkg update. Copy and paste the required packages from the video's description to install OpenVPN. Now we clear the OpenVPN config, write chevron space /etc/config/openvpn. Now type nano and the same path to edit the file. From the video's description, copy and right-click to paste the OpenVPN server config. In my example, the server bridge LAN is on the 2 range. Click Ctrl+S and Ctrl+X to save and close. Next type nano/etc/config/firewall. For redundancy, we will have DHCP servers on the server and client. The following is to prevent DHCP being served over the VPN on each side. Copy and paste the relevant section in the description. Then, Ctrl+S and Ctrl+X. Now type nano/etc/firewall.user. Copy and paste the firewall.user section from the description. Tapvpn in these lines will be the same interface name we had in the OpenVPN config files. Then, Ctrl+S and Ctrl+X. Now restart the firewall and ensure no errors. /etc/init.d/firewall space. Restart. Go back to the server's router, click System tab and reboot. Click VPN tab and OpenVPN, then click Edit. We now need to upload the VPN certificate files we created earlier. Scroll to CA and click the button. Click Upload File and find the CA file from the config folder. Same for DH. Then Server Certificate. And server key. Once uploaded, we need to select the files for CA, then DH, then Server Certificate, and server key. Now click Save and Apply. Then click VPN and OpenVPN. You should see now the VPN config is running. Click Status and System Log. Scroll to the bottom just to ensure everything is running. Here is where you can see if any issues. Now click Network tab and Interfaces, then Devices tab. Click Configure on the BRLAN. Click Bridge Ports and add the tapvpn adapter. Click Save and Apply. Go back to Interfaces tab, and then click Edit on the LAN. Click the DHCP Server tab. As we will have DHCP server on each side, we need to ensure they won't overlap. In this example, I will limit the server start from 100 for a 30 limit. Click Save and Apply. We now need to configure the client's router. Ensure you are accessing the client's router on any port other than 1, as during setup, we will be changing the IP range of port 1. The client's router should first be accessed via 3.1. First ensure you have SSH software installed on the client's computer, like PuTTY. If not, download this again as shown. We need to also check the date, and time is correct on the client's router. Click System tab and System to check this. If it is not correct, you can click Sync with Browser. Open PuTTY to SSH into the client's router. In this example, we use 192.168.3.1. Log in and type opkg update. Now copy and right-click to paste the required packages again from the video's description. Now we clear the OpenVPN config, write chevron space /etc/config/openvpn. Now type nano and the same path to edit the file. Now copy and paste the OpenVPN client config from the video's description. You would only need to change the remote host name or IP address to that of your server. In my example, I'm using 10.0.0.2. Ctrl+S and Ctrl+X. Go back to the client router and click System and Reboot. Once rebooted, click the VPN tab and Open VPN. Then click Edit. Like we did on the server, upload the VPN certificates and select these for CA, client certificate and key. DH is not needed for the client. Now click Save and Apply. Then click VPN and Open VPN. You should see now the VPN config is running. Click Status and System Log, scroll to the bottom just to ensure everything is running. Here is where you can see if any issues. Now click Network tab and Interfaces, then Devices tab. Click Configure on the BR-LAN. Click Bridge Ports and untick LAN 1. The main LAN of the client will only use ports 2 to 4. Click Save and then scroll to the bottom and click Add Device Configuration. For device type, select Bridge Device. In the name, type BR-LAN-VPN. Click Bridge Ports and select only LAN 1 and the tapvpn adapter. Then click Save and Apply. Now go back to the Interfaces tab, scroll down and select Add New Interface. In the name type LAN VPN. Protocol, static address. Then device select BR-LAN-VPN. Click Create Interface and then type for the IP address. My example is 192.168.2.2. And subnet mask is 255.255.255.0. Scroll back up and click the DHCP server tab. Click Set up DHCP server. Again, to separate the ranges, in Start, type 130 and set limit to 30. Now click Advanced Settings tab. For DHCP options, the DNS push to the clients, we will point first to the server and then a fallback to the client. So type 6,192.168.2.1. 192.168.2.2. So to summarize in this window, we have set the IP, the subnet, the DHCP range, and the DHCP options. Once set, click Save and Apply. Now click Network tab and Firewall. Scroll down to the bottom and select Add. For name, type LAN VPN. Then select Accept for input, output, and forward. Covered networks, select LAN VPN and allow forward to zone. Select 1. Click Save and Apply. Now plug your computer into port 1 of your client's router, which should now be on the 168.2 range. Reboot the router again, and once it is back up, access it by typing 192.168.2.2 into the web browser. Now, before we test the VPN, we will just temporarily disable the firewall on both the server and client devices' computers. Sometimes the firewall can prevent pings from being received, so we will just do this to ensure if there are any issues, it will most likely be the VPN config and not the devices sending and receiving pings. Depending on your Windows version, the exact steps may differ a little. My virtual machines are using the older Windows 7. Click Start menu, then type or click Control Panel. Click Windows Firewall and then again from the left side and turn it off. And then I do the same thing for the client computer. Once done, we will try to ping each end of the VPN. Click the Windows button and type CMD to get into the command prompt. From the client's computer, I type ping 192.168.2.1. This should ping the server's router. Then, from the server's device, I go into command prompt and type ipconfig. This will show me the device's IP, in my example 2.10. I then ping this from the client's computer to ensure device-to-device ping is working. I also check the other way from server device to client device ping. ipconfig on the client's computer to get the IP, then ping from the server. In my example 2.11. You can now enable your firewall again and retry the ping. There may be one of two methods for the VPN to work. 1. For the client's internet traffic to route through the server, or 2. For the client's internet traffic to go out through its own connection with only internal LAN traffic to be shared with the server. The default setup is internet traffic routing through the server. To check this, on the server, SSH into the router and type the tcpdump command from the video description. Now back on the client's command prompt, type ping www.google.com. You should see the request go through on the server. To show the example of not routing internet traffic through the server, SSH into the client's router and type nano/etc/config/openvpn. At the bottom, comment out the redirect gateway line with a hash. Then Ctrl+S and Ctrl+X. Now back on the client's router, click System tab and reboot. Once rebooted, go back to the client's command prompt and again ping google.com. You should not see the traffic going through the server. That's it for now. Thanks for watching Prime Tech Guides.